I want, sorry, Katharine, I'm going to leave you out of this. I want David and Tony to fight with each other. And for the sake of full disclosure, I'll be 100% on David's side on this. So it seems putting the two talks against one another, there were fundamentally different views on aggregation of heterogeneous predictions. Now, it's David was talking about aggregation of results across different models. Tony was across different experts, but I see the same issue, is that David took the view that you put out the envelope and that each of those models is one plausible view of the world, and so you don't want to discount any of them, and then what the scientists should give to the policymaker is what the envelope is. And I have to say that that's what we do in this identification analysis that that we do in econometrics. Tony took the view that somehow you want to pool them and come out with a probability distribution. You can do it by a pooling algorithm or by behaviorally, but that somehow you want to do that now. And I think that's actually a bad thing to do, because you lose a lot of information. You lose in the envelope approach. You get to see straight out the heterogeneity in the output of these different models, or it could be the heterogeneity in the output of different experts. In the pooling approach, however you do the pooling, you strip away all that heterogeneity and give the appearance as if there's some kind of consensus distribution. And just to broaden out where I don't work in climate change, but I've seen this quite consistently in macroeconomic forecasting. The Bank of England actually produces a consensus probability forecast. And yesterday we talked a bit about the fan charts, and I said the fan charts are a good thing yesterday, but actually a bad aspect of the fan chart is this. It's actually it's a consent. It's not a weighted thing. Actually the Federal Reserve does it as a weighted thing, but the Bank of England, they sit around the room and try to reach in the Delphic, Delphi sense, a consensus probability distribution, and that it obscures the fact that there's actually different people in the room who disagree with each other, because they have to come up with a consensus. So I'd like between the two of you, these are two good examples of the different approaches, and it shows up in lots of areas, not just in climate change.
I think that's right. I'm off the hook. I think you're going to put me on the hook, but I'm not sure.
Okay.
Aren't you in some ways looking for both also?
I think
Tony,
that's...
were you starting? I think Tony was actually starting.
Yeah.
It's on, is it? Okay. So, first of all, I completely disagree. To simply give the range of possibility is, I think, an abdication of scientific responsibility, because you're simply saying, I don't know where it is. It could be anywhere from here to... You don't have that feeling. Somewhere in the middle is far more likely than somewhere at the extremes. Almost everybody would make that judgment. So why can't you tell decision makers something that's actually useful to them, rather than abdicating and saying, I don't know where it is. It could be anywhere. Secondly, when you do aggregation well and effectively, you don't lose the extremes unless the people that are doing it agree for reasonable arguments that somebody who started out there was actually wrong. Okay? When you do an aggregation of this kind and you get the Rio perspective final distribution, it typically is almost as wide as all the distributions put side by side, if you like. You get that range, but you still do have a sense that the extremes are much less likely than the middle. You get a reasonable assessment of that situation. And I think it's just completely unscientific to say it could be equally likely to be anywhere between here and here, but it's not out there. There's a threshold. Everything is equally likely to, boom, nothing. Crazy. Almost as daft as you were saying other things were.
Did you
I guess I would just say from the assessment perspective, the goal for a long time has been really how do you represent the range of views in a consensus environment? And there's a strong sense that just giving a likely estimate, whether it's climate sensitivity or sea level rise or temperature projections or any parameter, is somewhat unsatisfying, in that you have just lost transparency around what experts think, at the same time that saying every model gets one vote and just giving the spaghetti across all of the CMIP5 archive also doesn't tell you all that much.
So I was going to start with a question for David, but then we switched the group. So this is actually a great opportunity to invite you to indulge in some behavioral aggregation on the following question. But first, a comment is that, Tony, I found your talk fascinating, but I interpreted it as a beautiful discussion of how you run expert groups to elicit information stuck onto this claim, which I don't believe that the best thing to do with a group of experts is produce a single PDF for deeply uncertain questions. So with that in mind, David, I've always been interested in the question about how you take a cloud like that and then combine it with all the other stuff that climate scientists know to answer a question like, if I drew a line across one of those fields, and let's say it encompasses, just to make it interesting, some of the noise at the end, but not the bulk of it. And I said, if I were down, for some specific decision, if I were down in that region, I would have a big problem. And I would first, should I take that seriously enough to go and commission an engineering study to figure out 12 different options for how to respond to that? And then, eventually, is there enough weight out there to actually pay for the insurance that one of those 12 options might imply? Maybe the three of you can indulge in some behavioral aggregation of your respective expertise on how you would set up such a process so that you would have the model results, the other expertise of climate scientists, and think about how you would answer that set of questions.
You can start.
Well, Mike, you start.
Well, your final point was kind of going to Tony in many ways. He's saying, in order to assess that insurance point, you want probabilities. And I think I wasn't convinced. So I've tried to stick.
Well, this is the first one, should I? You were saying the question. That's what you this nice phrase with the sort of the maximum range.
Maximum, yes.
The lower bound on the maximum range. Okay.
Yeah.
From the information in climate models.
From the information.
Yeah. So
yes.
if I gave you a specific, region across that chart, how would you think about adding whatever additional information that climate scientists know that they haven't been able to put in their climate models about whether that is a region I should worry about or not?
So in order to sound clever, I can give something of an answer. so I'm going to dodge the main point, which so what I would do, I would take that information as some sort of change in. And so in this case, you've got a large region. You're looking at whatever drying and warming of this amount. Have some sort of idea of that. I would then be perfectly happy to use rather more complex models in hydrological models and weather type models, and I would combine that information with, I guess it's some sort of expert knowledge of how that sort of change could be reflected in this region, and I'd use those models to fill in a picture. So the crucial difference of using those sorts of models is the problem I have. So I emphasize extrapolation. Yeah. So the point about these models is they are extrapolating. They're going from now into the future, 20, 30, 100 years. And we're trying to simulate the feedback processes, and that's what we don't have a good constraint on. What I want to do is step back from those. So these sorts of simulations would say, okay, a credibility of 20% decrease and a 6-degree warming in this region. Taking that to a weather model to fill in quite what that means for the difference between Paris and Lille or Lille and London would be a perfectly reasonable thing to do. And to, I guess, stress test the engineering options that you have. Yeah, so this comes, it kind of relates to the storylines kind of approach. You want to get from your decision makers what are their options and get some feeling about whether, I don't know, if you've got 3 options for a flood defence system and they cost 1 million, 2 million and 10 million, are you looking, does the 2 million get you an awfully long way? and kind of go with that. The thing that makes me worried, and I'd kind of like to discuss this perhaps more over lunch, but the thing that gets me worried is kind of how I see this whole problem. When we're going forward into the future and you're interested in some region, you're looking at flood defences in northern Netherlands or something like that, the change is, it is a totally interconnected system. So changes over Australia or the Southern Ocean could well be order 1 for your result, which is why you get down to this envelope. It's that's if you just act for the expertise in the region, you're going to lose what could be really important possibilities. So I guess it's maybe the problem of having 8 people in the room. The knowledge is not just within the climate scientists, it's within the non-linear dynamicists, it's with the philosophers, it's everywhere. There's really important knowledge all over the place, and I don't know how to bring it together. So really, I guess I've just said I don't know how to answer your question.
I
would do some of the different things early on. Sorry,
I'd like to say something that's sort of relevant, sort of tangential. The point about getting an aggregation into a single probability distribution is wanting to express what is known now, what is the best state of knowledge now, what is our best assessment of what's likely and what's unlikely. That's a single probability distribution. There is no need to have any notion of uncertainty around that particularly, except that in the sense that anything you measure has a measurement error associated with it, and we're sort of doing that. Where the issue about the quality of the data and the quality of the knowledge comes in is in a different context. If I'm wanting to know what is the current best assessment now for a decision maker to take an action on now, that is the distribution. It doesn't matter whether it's come from crap data or good data, that's irrelevant, okay? Where that becomes relevant is in thinking, how might this change over time as I learn more? Then it's important. Then it's important, for instance, to know that there were experts saying this, 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 and this, because over time, one or more of those people may be better vindicated. That's important to know at that point. Okay? It's important to know that there was some crap data involved in there, and that we could learn better, we could get better data. That's all about what might change in the future, but that's not where I'm working when I'm doing these elicitations. I'm saying, what is known now? So that we can take a decision now. GlaxoSmithKline need to take decisions now. The European Food Safety Authority need to give advice now. It might change. Everybody knows that these things, decisions change as information changes. We have to do it now. And that's why I say it's an abdication of responsibility not to give them that information in order to do it now.
I realise sort of trying and doing so badly in answering Rob, that maybe the problem I have with the approach you're advocating, as it applies to climate, so this is nothing to do with GlaxoSmithKline, but simply as it applies to multi-decadal climate change, is that I think the knowledge that we have now, the relevant knowledge that we have now, is so diffusely resident in so many different people. I think if you got 8 people in the room, you would inevitably have a very biased set.
2 quick points in response to this and Rob's initial question. I mean, I think this question of does knowledge creation happen in the IPCC process? Absolutely it does, and there are a lot of different ways you can see that. I think you can't drive synthesis science without understanding the gaps in a new way and thinking about how current knowledge interfaces with them. Rob, I don't know if this is at all where you're going, but to me, an interesting point is I don't think there's been, in the history of global scale climate change assessments, at all a decision-first orientation to how to assess climate model projections at the global scale. And I think that gets really hard because maybe to get to a decision-oriented assessment approach, you have to go through impacts. But I feel like thinking about how you start to layer a lot of these uncertainties on would benefit a lot. And at some point, I'd be curious to hear your thoughts about that.
Mark, can I just have just a very quick one thing?
No. Not without the mic.
Yeah. No, I know. Yeah. Just super quickly. The problem I have with what you just said is that when you gave all the information you just said, probability PDF now, different camps in the future, my claim is that for many, many problems, that you could then reframe your decision so it doesn't depend on the current probability distribution, but depends on that subsequent information you said. And many of our, say, you can certainly come up with regulatory processes. In certain ways, we framed up certain processes so they're more reliant on the crappy PDF as opposed to the more solid information you have in the future. But that's, maybe the more honest thing to do is say it's a crappy process that we ought to fix given our level of information.
Wouldn't that be nice?
Just to say, you're of course right.
You're abdicating your responsibility not to say that the process is crappy, as opposed to trying to come up with crappy information that fits their question.
Yeah, that's maybe, but just say, I agree entirely. There's a huge amount of learning within the IPCC process and collaborative information. But there is still the point of who's in the room. And I guess my lobbying position, because it's the way I see the climate prediction problem, is that it's one of non-linear dynamical systems going forward. How do I understand that change in a tractor? And those sorts of people are not generally in the room. So I do think you have, inevitably so. I mean, you were interested in changing rainfall and changing flood patterns and changing feedback processes. But the problem is one that encompasses an even wider range of people.
And it's almost a three-layer thing of who is physically present in the room in terms of the core set of experts, who is feeding into the process directly in terms of scientific inputs through review, through any mechanism, and then finally, how do you understand the broader decision-maker stakeholders kind of at the periphery of that process?
Yeah.
The models are in the room, and therefore all the nonlinear dynamics is in the room.
No. Whoa, what an awful thing to say. The models are in the room, and all the nonlinear dynamics of the models are in the room, and all the nonlinear dynamics and other processes of the climate system are outside the room.
Yes.
Bearing down upon it, yes.
Given the time constraint, we have, I propose that we collect. We have at least 3 more questions. So I propose we collect them, and somehow you try to remember them.
I'm hopeless at this.
So this question's directed mainly at Tony, although the other 2 speakers can. Okay. I'm not going to jump on Tony's super Bayesian claims like everybody else, but I have some questions about the process. I mean, I thought the presentation was very, very interesting. It seems like it's a very important process to engage in. So the 2 things that I was concerned about are, first of all, that in many issues of current contention, even experts have ideological biases, right? So you made a point of saying, I keep stakeholders out of the room for obvious reasons, but even amongst experts, there are going to be people who have ideologies. I mean, for example, in macroeconomics, there's a range of opinions, and you can clearly see that there are certain, even people with Nobel Prizes who have very strong ideological preconceptions. Probably the same thing is true in climate science, although I don't know very much about that. And so, I mean, presumably that's something which has to be taken into account in this kind of aggregation process. And another question which sounds similar but is not exactly the same, and this is maybe gets more related to David's presentation as well, is that in many of these contentious issues, there's a range of opinions, and there might be you might have some kind of sense in your mind that there's some kind of population distribution of opinions. Most of the expertise kind of is in this area, and there's some outliers or whatever. What's the right way to sort of statistically sample from the population? right? Because you might think, well, I should do a kind of a sample which represents the frequency in the population, but then the problem with that is you might overrepresent some kind of false consensus which is arising from sort of groupthink or emperor's new clothes phenomenon. You don't want to exclude these kind of outliers because the outliers, sometimes they're crackpots, but sometimes those guys turn out to be right. So how do you sort of square that circle?
Why don't you let them answer that?
No, we are out of time, so if we could.
Well, I've had interesting conversations with Tony, so I'd like to address a question to Katharine and David. David, early in his talk, said that the extrapolation is to unknown futures, and that depends on getting the physics right. But it also depends on managing the uncertainty in the physics that remains. And that's especially true at the policy interface. And so I'd like to ask a question. I'll phrase it 4 times in 4 different ways, just to keep things simple. Might it be that simpler models that are actually more wrong could be more robust to uncertainty and therefore more useful at the policy interface? Or to ask that question in a slightly different way, might better, more sophisticated models actually be less useful and more vulnerable to their errors than simpler models? Or to phrase that in yet another way, implicit in both of your presentations, and certainly in the IPCC procedure, is sequential specialization. You have the scientists who work all night long and build their models, and they pass their models on to policy people who use those models and get passed on further. But is that sequential specialization really a methodologically healthy process when we know that the models are going to be better next year, but we need to decide now, as Tony said? And the final, most generic way, and this is for the philosophers to keep them happy, is positivism really the right methodology? Positivism being the idea, there's a statue of Auguste Comte somewhere in the neighborhood, and that first learn the science and then you can control the system. But we can't first learn the science. And so is this specialization, developing of sophisticated models, which are then passed off to analysts, which are passed off to the policymakers, is that methodologically sound? And in fact, all this is a promo for my talk after lunch.
Yeah, but they will have. It's very different. Okay, so I propose that each of you wraps up, so responds to the last question, but if you want to add final comments on the general discussion. So Katharine, you want to start?
Sure. So on this first question of kind of in any sort of expert convening, whether it's an elicitation in whatever form or an assessment, who should be in the room, I think a classic way that has been thought of, for better or worse, is that you want to encompass the major mental models relevant. And Christian's point, I think oftentimes we think of that being topical experts, but oftentimes you really need the generalists in there as well to be able to make some of the bridges to what's decision relevant, how do you interlink those different assessments. And I think another interesting aspect is in terms of absolutely experts have ideological biases and frames, and it may be even worse than the Nobel Prize laureates, but there's also a difference in terms of how willing experts are to entertain different paradigms. And I think that's a really interesting dynamic that you tend to get in these assessment processes, like the SPM 70-person discussions. You will have experts basically ready to pitch their chairs across the room, and it comes down to different paradigms and whether you can kind of flexibly throw those into the air or not. And so anyways, all of those aspects of mental models across disciplines are really relevant. Are complex models good or bad? Both. I think in something like the CMIP5 architecture through time, yes, increasing complexity in terms of these processes that actually you can hope to represent in terms of equations. The complexity has really enabled pushes into aerosols and extremes and climate feedbacks and ice sheets. At the same time that you can say at the global scale, that's a big impediment because there are a lot of really simple experiments that should be happening, but all the computer time is going to this massive CMIP5 comparison. So even there, just on the climate side, I think that's a really important aspect. I think where complex models become really complex is where you're pushing into the deeper uncertainties. So a big thrust within the IAM space over the last decade has been to close the loop. So really to try to get impacts into these energy economy models so that you can maybe just get the right answer out. And what tends to happen is that they become big black boxes. I'll just give one little very quick description. For Working Group 2, at the end of the report, we were mandated to give a presentation to the IAM community. Working Group 2 co-chairs couldn't go, so I went. So I did a survey of all the Working Group 2 authors of how come you're not using these IAM models, and it was because they become these black boxes where they produce incredibly counterintuitive results in terms of the impact realm, and it's really hard to get at sensitivity analyses of why that's happening. And then absolutely sequential is not so helpful, and I hope I didn't make it sound like this is kind of a science into society providing a right answer. I definitely think it's about dialogue and learning through time.
Okay, I was just going to engage with the first one, the first expression of your point, but I agree very much with what you've just said. I think I do think simpler models tend have perhaps greater opportunity to reveal understanding that will help us constrain uncertainty, because we understand more of what's going on in them. It allows this sensitivity analysis, and indeed that's something that I've been thinking about a little bit in the context of integrated assessment models. The smaller ones, I guess, the DICE fund page, so that sort of model, and there seems to be something of a pressure to increase complexity more and more. And as a physicist, we've been thinking about the physics within those models, and it's very tempting to make the physical part more and more complex. And I have. My own position has moved to something to say, actually, you really don't want to make them complex. What you want to do is something much more like an expert elicitation, to understand what the experts think about the parameters that you have in a simple model. They can use the complex models to understand the system. But if you're studying the economics, you should have something simpler. And even if you're studying the global system, you should have something simpler. There's also just a kind of final point. I didn't talk about it very much, but this question of how bad does a model have to be to be ruled out? How good does a model have to be for it to be used? That kind of goes to this thing called the hawk moth effect, which Thompson named, which was designed to encapsulate the idea of something parallel to the butterfly effect, but uncertainty in parameters or model structure at the small scale. So how small, maybe at the finest scale, can lead to substantial errors in probabilistic predictions with a model. So that's what's encompassed by the hawk moth effect. So how accurate does it need to be? So the question is, does the hawk moth effect exist? And the slides I didn't show were sort of demonstration in the logistic map, and that something as simple as that. But that has raised a question, I gather, within the philosophy community of, okay, so you might see it in a low-dimensional nonlinear system, but would you see it in a really high-dimensional system, or would it actually collapse? Would you find that that there are constraints, as there are on the global energy scale? Would you find that there are constraints, that you've made the system now so complicated that you're identifying places where the nonlinearity is squashed, basically, that errors in some parts of the system actually don't matter? And I think to some extent that may well happen, but we need to understand it. We need to sort of accept that this could be a problem and go and try and understand how we would identify it, or how we would identify that it's not, how we get confidence. I'm not sure whether that meant anything, but
Okay, I'll talk about modelling first. Of course, we have to have the big models, and they will get bigger because people will want to put more and more science in, and they will try and get... This is part of the scientific progress and so on. But models are not reality. And any model, the question arises, is it fit for purpose? And different models are fit for different purposes. So when it comes to making broad brush statements, simple models are very often very effective. As you say, it's just a simple energy balance model will get you everywhere, as far as that envelope's concerned, more or less. But it's also very important that you don't just think of the model prediction, but you also understand the error in the model, what I call model discrepancy, the difference between the model and reality. This will typically, not necessarily, but typically be greater for simpler models. But with simpler models, it may be possible to better understand the model discrepancy. You have more opportunity, because the model is faster and mathematically simpler, to understand its behavior across the parameter space, which you can never do with the fastest models, so the slowest models currently available. So yes, the simpler models may be more useful, but the crucial part of that is to be able to understand where they're wrong and how wrong. Moving to your question, the question of who you invite to be the experts is a very big question, and I skipped over a lot of it. The only thing I mentioned was don't get stakeholders in. When we're talking about having a relatively small number of people in the room, there's no way we're going to, in any sense, sample or represent the community. That's not the objective of what we're doing. We want to get the range of opinion. So we deliberately choose people with wider and more extreme opinions, acknowledging that this is going to cause us problems when it comes to reconciling them in the aggregation process. But it's very important to get those things confronting each other in a way which is not as confrontational as it usually is in a conference type situation. So as I said, we find that people actually are willing to be cooperative most of the time about thinking about a sensible aggregation of them. Now, of course, you may miss things, and you get a different group of experts, you'll get different answers. That's inherent in the process. But what you're doing is you're making your best effort based on what's out there to get an answer today.
Okay, so let us thank our speakers.